hopefully you've got the hang of this now. Let's try two more, and then hopefully you'll be able to review this whenever you like and make sure you understand how to do these. 9p and 7p we could scale up to 63, which involves multiplication by 7 and 9, which is quite big numbers really when we look at the right hand side. Or we can look at the q's, and we've got 3 and 2. The lowest common multiple of 3 and 2 is 6. So let's do that. Let's multiply this first equation by 2 and this second equation by 3. First equation by 2 will be 18p minus 6q, and 2 times 78 is 140, and 16 is 156. And in the second equation, multiply this by 3, we'll have 21p plus 6q equals 39. We've made the q's the same. One is minus 6q, one is plus 6q. Same signs subtract, different signs add. So they are different signs, so we need to add these together. 18 and 21 is 39p. Minus 6q plus 6q disappears, and this is 156 plus 39 is 156 plus 30, which is 186, plus 9 is 195. 39p is 195, so p is 195 divided by 39, which is exactly 5. If p is 5, then that makes 7p plus 2q equals 13. Well, 7p is 35. 35 plus 2q equals 13. Let's get rid of the 35. 2q is 13 minus 35, which is minus 22. So q is minus 11. So p is 5, q is minus 11. Let's check it by substituting it into the other equation, which was the first equation. 9p minus 3q. Well, if p is 5, then 9p is 45. If q is minus 11, then minus 3 times that is plus 33, and 45 plus 33 does indeed equal 78. So p is 5, q is minus 11 is the solution. And finally, just to prove that it works either way, I'm going to look at this last example and try to eliminate both a in one method and b in the other method. So let's suppose we wanted the a's the same. So the lowest common multiple for 4a and 3a is 12a, so we'll multiply the first one by 3 and the second one by 4. Multiplying throughout by 3 will give us 12a minus 15b equals 69, and multiplying throughout by 4 here will give us 12a plus 16b. 37 times by 2 is 74, times by 2 is 148. So we've got minus 148. So in this expression we have 12a and 12a. It's got nothing to do with the minus 15b and the plus 16b. 12a and 12a, same sign, subtract. So if we subtract these, the 12a take away 12a disappears. Minus 15 subtract 16 is minus 31b. 69 subtract 148 is the same as add 148. So that's 70 plus 147. So that's 217. So minus 31b is 217. So b is 217 divided by minus 31. You'll probably need a calculator, but that turns out to be negative 7. So if b is negative 7 and 3a plus 4b is negative 37, well, if b is negative 7, then 4b would be negative 28. Add 28 to both sides. To get rid of it on the left, and we end up with 3a equals minus 9, so A is minus 3. A is minus 3, B is minus 7. If instead we chose to make the B's the same, we have 5b and 4b, so we'd need to make it into 20b. So if instead we multiplied the first equation by 4, we would have 16a minus 20b equals 92. And if we multiply the second equation by 5, we would have 15a plus 20b equals 30 times 5 is 150, 7 times 5 is 35, so minus 185. So here we've got minus 20b and plus 20b, same signs subtract, different signs add. So we would end up with 31a equals 92 minus 185 is minus 93. So 31a is minus 93, so a is minus 93 divided by 31, which is minus 3, as before. So if a is minus 3, and 3a plus 4b is minus 37, then 3a would be minus 9. Add 9 to both sides. So 4b would be minus 28. So b would be minus 7 as before. So it really doesn't matter which method you use, so long as you are mindful of whether you need to be adding or subtracting, so that the term you've made the same disappears and is eliminated from the expression. Please do refer back to these 6 examples. They cover all the possibilities. Good luck.